In this video, we're going to make some exercises about rational indices. First of all, let's see the index laws that we have here. So the 8th index law, we have a to the power of 1 over n is actually equal to the nth root of a. Okay, some examples. We can have, for example, a to the power of 1 over 2, some special cases. Let's say 1 over 2. That is equal to the second root of a, which we can just write down as the square root of a. So we don't have to write the 2 here. We can, but we don't have to. But when we have another value for n, let's say 3, so we have a to the power of 1 over 3, that one is equal to the third root of a. But a bit more complicated index law is the following one. A to the power of m over n. That one we can write down as the nth root, because the n is here the denominator, of a to the power of n. That is equal to, we can also write that down as, we can first do to the power of m and then take the nth root, so that becomes like a to the power of m, and we take the nth root of that. That is also something we can do. So this is the 9th index law. Maybe examples with values. Here, for example, we can do 9 to the power of 1 over 2. That is actually equal to the square root of 9, which is just equal to 3. What else we can do is 64 to the power of 1 over 3, for example. That is the third root of 64, and that is equal to 4. Okay, and then here, so we can have 4 to the power of 3 over 2. We can write that down as the square root of 4, because the 2 is here in the denominator, and we do that to the power of 3. And the square root of 4 is 2. We do it to the power of 3, and that is equal to 8. Okay. Let's do some exercises. Let's go to example 4. Example 4 here, and we have to simplify this. A, we have 49 to the power of 1 over 2. To the power of 1 over 2, we can write down as square root. So the square root of 49. Square root of 49 is equal to 7. And then B, we have 27 to the power of 1 over 3. So that is actually the third root of 27, which is equal to 3. And then here, we have 49 to the power of negative 1 over 2. We have a negative exponent. So what we can do is, it's here in the numerator, because you can see that as 49 to the power of negative 1 over 2 over 1. So because we have a negative exponent, the numerator will go to the denominator. So we can write that down as 1 over 49 to the power of 1 over 2. And to the power of 1 over 2 is just the square root. So we take the square root of 49, which is equal to 7. So we have 1 over 7. Okay. And then D, we have 27 to the power of negative 1 over 3. So again, we have a negative exponent. So we move that to the denominator. So that becomes 1 over 27 to the power of 1 over 3. To the power of 1 over 3 is the third root of 27 here. So the third root of 27, we solve that in B, that is just equal to 1, and that's just equal to 3. So the answer here is 1 over 3. Let's go to example 5. Those are a bit more complicated, so evaluate without using a calculator. So we have 8 to the power of 4 over 3. Okay, when I see that, I see here a 3 in the denominator, and 8 I can write down as 2 to the power of 3. Let's first copy the question. So 8 to the power of 4 over 3 is equal to, the 8 is 2 to the power of 3 to the power of 4 over 3. We can write that down as 2 to the power of 3 times 4 over 3. And we have 3 times 4 over 3, so the 3's they cancel out. So we have 2 to the power of 4, which is equal to 16. And then here, 32 to the power of negative 2 over 5. So I have here to the power of negative 2 over 5, but I have 32. Like, you can solve that in two different ways, but let's maybe focus first on the negative exponent here. So negative exponent means that we move it to the denominator. So this is equal to 1 over 32 to the power of 2 over 5. And the 32 we can write down as 2 to the power of 5. That to the power of 2 over 5, that becomes 1 over 2 to the power of, you can use the third exponent, the index law, that is 2 to the power of 5 times 2 over 5. So the 5's cancel out, so we get 1 over 2 to the power of 2, which is 1 over 4. That's the answer.